Hey guys, I hope you are doing well. I am Pathik here with new video of coding pi series. As I said in previous video, we will see how this mathematical constant pi appears in different patterns, and using those patterns we will calculate approximate value of pi. So let's start with today's topic. Leibniz's pi formula. Also known as Gregory's series for pi. This Leibniz's formula suggests us that if we add reciprocals of odd numbers with alternate plus and minus sign till infinity, we will get this value of pi divided by 4. Strange? Huh? Just to get a feeling about how this infinite series converge, I will show you this beautiful animation from one of 3 blue 1 brown's video. As we just saw how this series converges to the ratio pi divided by 4. Now let's see how to use this series to get approximate value of pi. So to get pi, first we will calculate right-hand side, say s. Then we will multiply s by 4, so by doing this we will get an approximate value of pi. Since now we know that how we can get pi from Leibniz's pi formula, let's see what algorithm to use. So we have this series S. As I mentioned in previous video, for series having summation pattern, we will initialize our series S with 0. Then we will add 1 divided by 1 in 0. Then we will add negative 1 divided by 3 in previous term. Then we will add 1 divided by 5 in previous term. Then we will add negative 1 divided by 7 in previous term. And so on. If we do this for infinitely many times, we will eventually get our series S. But before diving into our algorithm with operations, let's have a look at our algorithm from previous video. So here you can see that we are adding reciprocal of square, simply a 1 divided by I squared term. But in this Leibniz's series things are a bit tricky. Here we are adding reciprocals of odd numbers with alternate plus and minus sign. So in our code we will have to add something which will give us odd numbers in denominators and alternate plus and minus sign in numerator. There are 2 ways to express odd numbers. One where I starts from 0, and one where I starts from 1. So respectively there will be 2 ways depending on initialization of I. So in this 2 algorithms difference can be seen in term which we are adding. Let's consider the one where I is initialized from 0. So here, 2 times I plus 1 in denominator accounts for odd number, and minus 1 raised to I accounts for alternative plus and minus sign. Minus 1 raised to I will be positive for even values of I and will be negative for odd values of I. Similar logic is there for next algorithm where I is initialized as 1. So this is our algorithm. Now if you have not watched my previous video you may ask why n iterations. To get this series we will have to add infinite terms. Right? But that's not possible since our computer or machine is not made to do such infinite tasks, so that's why we will have to do n iterations. And this is also one of the reasons why it's not possible to have exact value of pi, since we need infinite iterations. Now let's see how this algorithm will work. To show this, I am using this algorithm where I is initialized as 0. So consider first iteration where I is equal to 0 and s is equal to 0. First we are adding minus 1 raised to 0, divided by 1, in 0 as discussed earlier. That is we are assigning s to be 0 plus 1 divided by 1. And I will get incremented by 1. So now we have s equal to 0 plus 1 and I equals to 1. Now consider secondary iteration. Here I is equal to 1 and s equal to 0 plus 1. Since I is 1 we will add minus 1 raised to 1, divided by 2 multiplied by 1, which is minus 1 divided by 3, in 0 plus 1. And again I will get incremented by 1. So now we have s equal to 0 plus 1 plus minus 1 divided by 3 and I equals to 2. So at nth iteration, we have this series S, and I will become n. But since iterations are over, there is no use of I now. So, we will calculate value of pi equal to 4 multiplied by S. Now let's see coding part. This is approximate value of pi to 18 decimal places, which I showed here just for reference. For coding, I am using Python language, but you can use any other language of your choice since algorithm is same. So let's see our first example where number of iterations are 1000. As we discussed earlier, we will initialize our series S with 0. Then for 1000 iterations we will use this for loop. In Python, for I in range 0, 1000 means that I will take values from 0 to 1000 where 1000 is exclusive. So after doing this for 1000 iterations, we will output this value of pi equal to 4 multiplied by S. As you can see that we get value of equal to 3.140 and so on. That is, we are getting approx value till 2 decimal places for 1000 iterations. Now for any other iterations coding part will be same, difference will come in for loop for number of iterations. So for 10,000 iterations we get value of pi equals to 3.141 and so on. That is, we are getting approx value till 3 decimal places for 10,000 iterations. And if we go on doing this for higher iterations we will get more and more precise value. For example, here for 10 raised to 6 iterations, we get approximate value of pi, accurate till 5 decimal places. So now you can try yourself this series with some other language for practice. If you have any suggestions, feel free to drop down in comment section. In next video I will show how this pi appears in series including multiplications instead of summations. So stay tuned for next video. Thanks for watching.